Hello everyone and welcome to PC Retro Tech. This week's video is the 1000 subscriber special. Yeah, we finally made it after a couple of years of effort to 1000 subscribers, so thanks to everyone who's subscribed to the channel. So in this week's video, what I'm going to do is celebrate by writing a small CGA game, or at least starting to write one. It'll be a series that runs on the channel for a while. And I'm also going to give a little bit of a look behind the scenes at something that I've been working on over the past few weeks, and that is to clean up my collection and to put it onto shelves. So I'll give you a bit of a look at that, how everything's stored, and then we'll get right into coding up the game. Well, here we are on YouTube. Just put PC Retro Tech in the search bar and you'll see the 1000 subscribers. And under videos, there's now 61 videos going back almost 2 years. So it's mostly been hardware, games, demos, a little bit of programming. And I used to make a video every week, but I found this was just too much if I wanted to do decent research and a little bit of coding as well. So I dropped back to one every 2 weeks. This has been a lot better, I think, for the channel. So the most popular video so far has been the IBM EGA one. That's the second most popular. And one that didn't surprise me at all, because I really enjoyed making the video, is the one on the IBM Model 30, which now tops the channel at over 4,000 views. So obviously we cover about the first 10 years of PC history, although there's some other stuff in there as well. There's one on the TI 994A, and I think there's even a Commodore 64 video. And there is some later stuff as well. But the thing that I've really enjoyed the most about the channel, and the reason that it's not monetized at the moment, even though I'd be eligible, apart from the fact that it's just a hobby and I have a full-time job, is that I really enjoy the comments section. So many people are contributing really insightful comments, information that I wasn't able to find, or stories from way back in the day, when they were kids playing around with these machines. And so I've really loved that, sharing my hobby with other like-minded enthusiasts, and have even reached out to some people outside of YouTube who've become friends just from this channel. So there's plenty more to come, and I hope that we can crack the 10K barrier. Let's hope for another great 2 years on the channel, and thanks to everyone who's contributed so far to get us to this point. Well, I promised to show some of the shelving that I've been putting up over the Christmas New Year period to get some of the junk that I have off the floor. You can see floppy disks, zip disks, hard drives, and up the top is my video card collection. It's all in buckets sorted according to type. There's even some on the top here, and over here there's more floppy disks and so on. All of this shelving is in my kitchen, so there's another set here, and you can see that I've got equipment here for repairs and some other cables in boxes, CD-ROMs. I think most of that is SCSI stuff there. I won't show everything that I have because there are actually some things that I want to be a surprise on the channel, but I'm going to show you some of the racks of PCs that I have. This is the top shelf of one of the set of shelves of PCs that I have, and these are all either new boxes or very, very close to it. So one day I'll be able to build those up into virtually brand new PCs. And just below it there's a machine just coming into view there. I'm not going to show that. That's a teaser for one that's coming up on the channel. And I guess there'll be some people trying to identify that now based on the machines that they own. And on the bottom of this set of shelves, there's some machines that you've seen on the channel before. I apologize for the lighting. There's not any natural light in this part of my house. But there are two 486s on the top there, and you can see my IBM PC and a 286 next to it that I've shown on the channel before. And just above in the middle here is my compact 386, which we've seen on the channel as well. Now, I didn't show you my second set of shelves with machines that are more recent all the way up to the modern day. I'm in my cellar at the moment, and these are the older machines that I either purchased very, very cheap, like 10 euros each, or maybe even found on the side of a road. And I apologize for the lighting in here. There's not very much I'm going to be able to do about that. There's nowhere to set up lighting or a tripod. The other side is more of the same, and the lighting is again pretty bad here, so the focus is going to be right out. But it's just more machines that are very generic in nature and not that interesting. In fact, some of these don't even have parts in them. They're basically just there as spare cases, or maybe I'll build them up into a machine one day. Well, I hope that you enjoyed this little look at my collection, and obviously I've been collecting a few decent computers a year now for quite a few years, and lots of other, components and parts, especially when they come up cheap online. So I will show some of that on the channel in the future, so look out for that. But for now I want to get back to the topic for today, which is programming a CGA game. And I've decided that I'm going to write a top-down shooter. So in order to do that, I'm going to need to start putting together some assets for a game. Well, if you know anything about CGA games, you know that the 4 colours that they have look pretty gaudy. There's a few different palettes you can choose from, but you don't get much choice within a given palette. So what I've done here is written a program that allows you to change the background colour and also dithers the foreground colours, and occasionally you'll hit a background colour which really makes it look like you have many more colours than you really do, and it doesn't look too bad. For example, this one here. And if you scroll through far enough, you'll eventually hit one like this, for example, where you have red, orange, yellow, green, light blue, dark blue, magenta, a kind of grey colour, and some other shades of yellow or brown. And so this really makes it look like you have many more colours than you do. There's still only 4 colours here, but just by alternating the pixels and by setting that background colour, it can really make it look much more colourful than it really is. So I'm going to use these colours in the game, and that'll hopefully pretty it up a little bit and make it more enticing for the player. In order to draw graphics for the game, I'm going to use PC Paintbrush, and the reason I'm doing that is it has some neat tricks. So under miscellaneous here, I can actually change the palette. So if I click with the left mouse button here, it'll switch to the alternative palette, and if I press the right mouse button, it'll select the high intensity version of that, which matches what we had in the palette program that I wrote in assembly. The other thing I can do is right click on background here and cycle through all the background colours, so I can actually select precisely the colours that I was using in that program that I wrote. So now the other thing that I need to do is to set the background to blue, because my Sprite routine assumes that that's the case. And then I can go ahead and draw a little ship for use in the game. Well, this is what I came up with, and I'm not the best pixel artist in the world, but I think this will do just fine for a homebrew game. There's probably some viewers out there with better graphics skills than I have, and if you want to submit some graphics, go ahead, so long as they're in PCX format and using this same palette that I'm using here. I'll certainly consider them. There's a link in the description to my GitHub account, and you can just make a pull request there. As I say, I won't guarantee that I'll accept them, but if I like what I see, then we might put them in. You can also just take the code for this game and make your own sprites and put them in. So this is got to be converted now into a actual Sprite program, and that's done using a Sprite compiler. So I wrote one of these a while back. It's a 2-stage process. First it takes the PCX file that this PC Paintbrush produces and converts it into a .dat format, which is basically just the same layout as the pixels would be in CGA memory. And the second part of the process is to take that .dat file and compile it down to a little assembly language program that draws precisely that sprite as fast as possible. Now, of course, shifting sprites by 1 pixel, 2 pixels and 3 pixels is a really slow process, because there are actually 4 pixels in each byte in video memory, and shifting is really slow. So it actually produces 4 different versions, each offset by 1 pixel, so that we can just select the right one at runtime instead of doing the shifting on the fly. And this is much faster, and it's what gives the game its very high performance. A while back, a viewer asked in the comments section if I wanted to get into CGA game programming, how would I go about that? For example, if I just wanted to put a box on the screen and move it about with a keyboard, what would I do? And I think that's a great question, and given that this is a 1,000 subscriber special, I think it's a great opportunity to answer it. So we've talked before about how to draw to the video screen. First of all, you need to get into video mode, which means calling an interrupt, and you want to set video mode 4, which is the 320 by 200 for color graphics mode. But then it's really straightforward. You just need to write the pixel information into the array in memory at segment B800 and offset 0000. So Boolean provides this make far pointer, which gives you a pointer to that region of memory, and it just behaves like an ordinary C array. You put values into that array, those are pixels that will appear on the screen. That's really all there is to it. And we've talked about animation and other techniques before on the channel. So instead of going into a great deal about the graphics today, what I want to do is discuss something that's a little bit more complicated, and that is keyboard handling. Now, Boolean C makes this quite difficult for you. There's a key pressed function which tells you if a key has been pressed but not which one, and there's a get char which really just waits for the enter key to be pressed before anything happens, so it's not very useful for games. So if you want to take control of the keyboard, you really have to do that at quite a low level, and the way it's done is by writing an interrupt handler. So what happens when a key is pressed on the keyboard, an interrupt is generated, and the CPU looks in a table of interrupt vectors, and the one corresponding to the keyboard is number 9, and this gives it the address of a function to call in memory. So every time a key is pressed, an interrupt handler, which is a function, gets called. So what we want to do is replace that function with our own. So basically the first thing that we have to do is to store the old keyboard interrupt handler, the address of that. So we get it out of the interrupt vector table and store it in our pointer, and then we put our keyboard interrupt handler, which is the address of our function, into the interrupt table. So that's setting up the keyboard. So once we've done that, we've taken over the keyboard, and every time a key is pressed and interrupt 9 is issued, our function new keyboard interrupt will get called. And when we're done with our program, we want to exit back to DOS, and of course we just return the old keyboard interrupt handler back into the vector table. So the old handler will handle the keyboard. So let me show you how this actually looks in practice. So this is our function here that we're going to call every time a key is pressed. It's just like an ordinary C function, except it has the word interrupt in it to tell it that it's an interrupt handler. And this is where we store the old one. It's a function pointer. So once we get that pointer out of the vector table for the old interrupt handler, we store it here for safekeeping, and we replace it with a pointer to our function. So let's take a look at how this function actually works. In order to get information about the key that's been pressed, we have to look at port 60 in hex, and Boolean C has this input port function, INP, which allows us to read from port 60. And there's two parts to this. If we AND with 07F, we get the scan code of the key that was pressed, and each key on the keyboard has a unique scan code, and you can look up tables of this on the internet. And the next bit along, the bit at hex value 0x80, is whether or not the key is down or up. Obviously, if you press a key and you release the key, there are two different events that have happened there. So you need to be able to distinguish those, and so that bit tells you which of those things has happened. So the other thing that you have to deal with, of course, is extended scan code. So I make two arrays here. One of them is for all the ordinary keys, and one of them is for extended keys. So some of them have different kinds of scan codes. They're actually 2 byte scan codes instead of 1. You can probably do with not worrying about those for first attempt. So a lot of this code goes away, and the thing that we really want is this last line here. It'll store into the key state array whether or not the key has been pressed, and it tells just by ANDing with that OX80 that I talked about. Now there's a little bit of a sort of handshaking protocol that you need to go through when dealing with the keyboard, and so there's some other things that you have to do to let it know that you've dealt with this key press. And so there's some other ports that you need to read and write from. Now this is for an original PC keyboard. If you have an AT keyboard or something later, then the handshaking protocol is a little bit different. So you'll have to look that up online. And the final thing is that when you finish with the interrupt, you finished handling the interrupt, you let it know by outputting to this port 20. So that's all there is to it. Once you've done that, then basically every time a key is pressed, its value in the key state array will be a 1, and when it's unpressed it'll go back to being a 0. So if you want to know which keys are down at the moment, you just need to look in this array. It's really that simple. And if I go down into the main program where I actually use this, you can see all I'm doing is I have a scan code for each of the keys on the keyboard, and I just look at the corresponding byte in the key state array, and if it's a 1, then I know that key was pressed, and then I can deal with things appropriately. So for example, if I want to move a sprite around the screen, which is what I want to do next here, I can change the direction that the sprite is moving according to whether a key has been pressed. So for example, if I press the up left arrow, then the X offset has to go down by 1 and the Y offset has to go down by 1, and then of course I can just move the sprite by that offset. So that's basically how it works. That's how you move an object around the screen. You just keep looking at that key state array. Has the key been pressed or not? If it has, update your offsets and move your sprite. And so that's all there is to keyboard handling. Well, this is what it looks like now, and you can see that I can move it back and forth with the keys on the numeric keypad. In fact, I can actually move it all around the screen at the moment. I'll probably eventually constrain it to just moving along the bottom here, because eventually the idea is that the enemies will come down towards the ship and will shoot from the bottom of the screen. But for now I've just got it so that I can move it anywhere within the viewable area of the screen without wrapping around. Now obviously I have to draw some sprites for enemies, but I'm not going to go to the trouble of doing that now. What I'm going to do is just put in some circles, triangles and squares of various colours so that we can simulate enemies, so that we can get the game dynamics working. And in a later episode we'll fill in all of that extra detail like coloured sprites and making it look a lot prettier. Well, I'm back in PC Paintbrush, and what I'm going to do is create some enemies here. So the first one will be a circle using the purple and blue, and I've also added some additional patterns here that just weren't there. One with the green and blue and another one with yellow and green. And so that gives me 3 different colours that I can use for enemies, and I'll make one a square, one a triangle and one a circle. And then I'll make 3 sprites, which will be enemy 1, enemy 2 and enemy 3. Well, this is how it looks with those sprites coded up, and I just have them now moving down the screen, and every time it gets to the bottom of the screen and disappears, it reappears at the top of the screen in a random location and starts moving down again. Now at the moment I can still move the ship about, but of course the sprites just run right over the top of one another, and eventually I'll need to set it up so that this isn't possible. But the next thing that I really need is some kind of weapons fire, and obviously if I have a little 2x2 sprite coming out of the front of the ship here, that will work. Eventually I'm going to need something a little bit more custom than that, I think, because the sprite machinery is pretty heavy duty for a little 2x2 sprite, and I can probably write something much faster directly in assembly language just for the weapons fire. But for now I will use a sprite, and I've also noticed that I have 2 of the sprites always at the same Y location on the screen, so I'm going to fix that as well so that they come in a more random way. Well, I've coded that up, and firstly I've made the ship move faster left and right just by jumping more than 1 pixel at a time. And also, if you hold down the control key, it'll fire up to 5 missiles at once. You can fire them one at a time if you hit the control key just once, but they have to go off the screen before they can be reused, and that just simulates the weapon having to be reloaded again. So obviously when they hit the targets at the moment, nothing happens, and you can see that they just go straight through, but later on we'll code it up so that they actually make the targets disappear. Now everything's going nice and smooth at the moment. I've made the missiles go up the screen at a nice rate as well, so it doesn't take too long. You don't have to wait too long before you can press control again, and it feels like it's playing well. So the next thing I need, of course, is some nice scenery for the clickbait. So I'm going to draw a background with a kind of mainland on this side and some islands, and then some interesting things, joining them and on the islands, so that it actually looks, more enticing as a game. I don't think it looks too bad. I mean, for a 4-color game, it really looks like it has more than 4 colors at the moment because of that dithering. So I'm really pleased with how this is working out. Let's see how we go with drawing a background for this. Well, this is what I came up with, and as usual, my drawing skill leaves a lot to be desired. But this is just a basic mock-up of what could be. Obviously the scenery will have to be procedurally generated in the final version, because the object will be to have it scrolling down the screen at the same rate as the enemies, so that they appear to be fixed with respect to the scenery and the ship appears to be flying over the top of it. So there's a long way to go. We're going to have to add hitboxes, scoring, sound effects, maybe cutscenes, opening, credits, and so on. So there's a lot to be done, and we'll want to add music and obviously some decent sound effects. So that'll come in a later video. Unfortunately the weekend is closing in on me here and I have to give it up for this week. I think the next video is likely to be back on a hardware related topic again, but we will get back to this very soon, I promise. But that's all for this week. Thanks very much for watching, and we'll see you in a later video. Bye.